And we're back. This is called IVM 123 because we're making an isotropic vector matrix with three tetrahedra, two of which are there in front of us. This is the same old book covers demo that we were going into earlier, except this time the book covers, which are flat on the table, you could say, at 180 degrees, have a longer spine. Before, the spine was the same length as the other edges, so they were all red, and now the spine is yellow because it is 2 second root of 2. And that makes this cross section, or the book covers, define a square. If I tilt it right, you'll see that basically we're dealing with a square on the table and another right triangle being the page, going back and forth. You see it in profile there. Now tilt it. You can almost see that it's square, but there we go. With perspective, it's kind of a little bit difficult sometimes to see the relationships. But there you see it's clearly, we're looking down on a square, the page going back and forth. Now we're going to switch to the two-page version. This is something David Koski has explained to me at some length. I'm rendering what I think of as mostly his ideas in Visual Python, practicing some of my computer graphics skills. Anyway, so here we have two so-called pages, and I pause it where the pages are straight up. And I use the synergetics volume. It's actually being computed really quick. Some code for it in the background. And the volume is 1, which means that this octahedron in that position, when everything's nice and square, is 4, because there's 4 such tetrahedra. Now there's another tetrahedron which I haven't gotten to yet, called the inadvertent tetrahedron, and it's made by taking the two different colored edges, the green one and the purple one, and keeping the others red. And we're going to look at that next. The point is you can take these two complementary tetrahedra here and add this one other inadvertent tetrahedron and fill space. And in the case where we have an octahedron here, I should say a regular octahedron, the inadvertent tet is a regular tetrahedron of volume 1. And therefore, the space-filling thing that we get is the isotropic vector matrix, the pure one where all the edges really are the same. Topologically, we have variations by letting the sort of the squares of the octahedra turn into rectangles and stuff like that. That's what we've been doing in these videos, is distorting the IVM. But the emphasis here is on using a square basis of book covers, getting a regular octahedron, regular tetrahedron, and deriving through those three tetrahedra that we got the pure IVM. It's kind of a special case of a more general case. So I hope that was elucidating for you. Again, I didn't show a huge number of tetrahedra all at once, but I think you can imagine what you didn't see. Talk to you again. Bye.